All right, number 7, we're going to be working on the same type of problem. We're going to find the principal needed. So we're looking for P to get the given amount. So we start out, again, we're going to be using the compound formula because I see compounded quarterly in the second part. So A equals P times 1 plus R divided by N raised to the NT power. All right, so what the book did is they went ahead and moved this over. So let's do that. We have A divided by 1 plus R over N raised to the NT power equals P. So when you divide that, this is pretty much what we're doing. So it's the same formula, just manipulate it to find P. All right, so we're given that the present value is 400, and then 1 plus the interest rate is 8%, so 0.08. It is compounded quarterly, so divided by 4. And we're doing this for 3 years, so it'll be 4 times 3, which is 12. All of this equals P, so we just plug it in like that. So just manipulating compound interest formula, we can solve this. So again, 400 divided by, open parentheses, 1 plus 0.08 divided by 4, close, and then we're going to raise it to 4 times 3. We'll just put a 12 here, raise it to the 12th power. And we get 31540 because this 7 will round the 9 up, and then the 9 will carry over. So 31540. So P equals 31540. Okay, so number 8, we want to know which of the following 2 rates would yield a larger amount in 1 year. 9% compounded quarterly, or 9.5% compounded annually. So yield, I believe we want to use the effective interest rate formula. Which is 1 plus R divided by N to the nth power minus 1. Let me go back and verify that. I haven't used this formula very much, but let's make sure that we're using the right one. Is it going to pop up for us? Let's try it again. Textbook. There we go. Okay, so effective interest rate. Right here, 1 R divided by N minus 1. And then if they did continuous, E to the R minus 1. Okay, so that looks good. We're going to do this formula twice for 9.5, compounded once a year and then quarterly. Okay, so that'll just give me different values of N. So for compounded, 9% compounded quarterly first, 1 plus 0.09 divided by 4 raised to the 4th power minus 1, compared to the other value, 1 plus, and it was 9.5, so 9.5 would be 0.095, because 9 and 1/2% as in percent decimal form is 9.5%. You just do 1/2 and convert it to a decimal. So that's not decimal form, but it's decimal percent form. Then you move it over twice, and we get this. And then it will be divided by 1. Raised to the 1st power minus 1. So it's just 1.1095 minus 1. So we'll compute both of these and see what we get and see which one gives us better effective interest rate. So parentheses 1 plus 0.09 divided by 4 raised to the 4th minus 1. That gives us about 0.093, or it gives us about 9.3%. Okay, and then over here, that will simplify to just 1.095, because you just divide by 1, adding that, and then we would subtract 1. So it should just give us 0.095, which is about 9.5%. So it gives us about 9.5, exactly the same. So it looks like the 9.5% would be the better, in this case, using effective interest rate.